Hi, everybody. So this is the third problem set that I had given you to try and get you ready for the upcoming test on Thursday and Friday. Um, so we might as well just get right into it. An airplane accelerates down a runway at 3.2 meters per second squared. Um, Sorry about that. So 3.2 meters per second squared for 32.8 seconds till it finally lifts off the ground. Determine the distance traveled before the takeoff. So what we start you out with is an acceleration of 3.2 meters per second squared. Last time I checked, you get on an airplane and it's not moving, so the initial velocity is going to be 0. And it's going to go for 32.8 seconds. That's your time. So what we don't care about is the final velocity, but we do care about the displacement. So the equation that we're going to be dealing with, VI, AT, and D, I would assume is going to be D equals VIT plus 1 half AT squared. So we're going to be solving for D. VI is 0 times 32.8 plus 1 half times 3.2 meters per second squared, all for that 32.8 seconds squared. So now we get the old calculator. So D is going to be, this is going to turn to 0, plus 0.5 times 3.2 times 32.8 squared. 1882.72 meters. So this times that squared, and it's just the 32.8 that gets squared. It's going to give you 1882.72 meters. Next, our car starts from rest and accelerates uniformly for 5.21 seconds, so automatically we know our VI is 0, and our acceleration is 5.21. I'm sorry, that is not our acceleration, that is our time. 5.21 seconds over a distance of 110 meters. Determine the acceleration of the car. So now we're looking for the A. So VI, A, T, and D. I guess we're going to go back to D equals VIT plus 1 half AT squared. I'm hoping that you realize that I'm giving you these to get you out of the habit of just throwing negative 9.8 in for A. So we had one before where I gave you a weird acceleration. This one we're solving for the acceleration. It's not just negative 9.8. That's only for projectiles on Earth. So we can start plugging in. 110 equals 0 times T plus, which is 5.21, but whatever, that's going to be 0 anyway, plus 1 half times A times 5.21 squared. So 110 equals, that's going to be 0, so I'm going to get rid of it. 0.5 times 5.21 squared, that's going to be 13.57 A. So all I did here was I took 5.21 and I squared it and I multiplied it by a half. So now I brought the A down and my coefficients have come down also. So now I'm going to divide both sides by 13.57. 13.57. 10 divided by 13.57. It's going to be an A of 8.106 meters per second squared. Sound good? Okay. Upton Chuck is riding the giant giraffe at Great America. It's a theme park in the Midwest. If Upton free falls for 2.6 seconds, what's his final velocity and how far will he fall? So now we're looking for final velocity and D. So we're going to have to do two different equations. We're going, I'm assuming he's going to start at 0 because we're dropping him. The acceleration is negative 9.8 and the time is 2.6 seconds. So let's see, we can do final velocity, that's probably the easiest. VF equals VI plus AT. So VF, which is what we're looking for, equals 0 plus negative 9.8 times 2.6. Negative 9.8 times times 2.6. Negative VF is going to be negative 25.48 meters per second. So there's the first answer. And then the displacement, I'm going to say, let's use D equals VIT plus 1/2 AT squared here. So D is going to be, VI is 0 times T is still going to be 0 plus 1/2 times negative 9.8 times 2.6 squared. So 2.6 squared is 6.76 times negative 9.8 is negative 66.24 times 1/2 is a D of negative 33.12 meters. So those are the two answers for that question. Final velocity and displacement. Race car uniformly accelerates uniformly from 18.5 to 46.1 meters per second in 2.47 seconds. Determine the acceleration and the distance. So VI is 18.5, VF is 46.1, the time is 2.47. So we're looking for the acceleration and the displacement. All right. My guess is going to be, let's find the acceleration first. And I think VI, VF, A, and T, we should do VF equals VI plus AT. So 46.1 equals 18.5 plus A times 2.47. So let's see, I'm going to subtract 18.5 from both sides. 46.1 minus 18.5. It's going to be 27.6 equals A times 2.47. Divide both sides by 2.47. 27.6 divided by 2.47. That should give you an acceleration of 11.17 meters per second squared. So that's the first little bit. Now for the second part, VI, VF, T, and D. Let's see, I think the equation that we could use, there's a couple of them. I don't usually advocate for doing this, but we solved for the acceleration, and I actually trust that we did it correctly. So I think the best equation to actually use is going to be VF squared equals VI squared plus 2AD. I think that's a good one. I mean, you could do it another, there's probably, you could do the VF, D equals VI minus VF over 2 times T. You might be able to get away with that one, but I'm just so used to using this. Let's give it a shot and see what happens. So 46.1 squared equals 18.5 squared plus 2 times 11.7 D. I'm just rounding down here. I'm sorry, 11.17 D. So 46.1 squared, 46.1 squared, that's going to be a big number. 2125, I'm rounding down. 18.5 squared, 342. 11.17 times 2 plus 22.34 D. So this times this is this squared is this squared is this. Next thing we're going to do is going to subtract 342 from both sides. 2125 minus 342, 1783 equals 22.34 D. Divide both sides by 22.34. to have a D of 79.8 meters. So that's that. You could have used the other equation. I think you should have gotten 79.8 as well if you used the other equation. So let's see what's next. On the moon, a feather is dropped from a height of 1.4 meters. The acceleration is 1.67 meters per second squared. Determine the time it takes. So VI is going to be 0. A is negative 1.67. T is what we're looking for, and the D is 1.4 meters. So we don't care about VF. I would say D equals VIT plus 1/2 AT squared. This is bleacher ball if you didn't notice. So we're dropping something, so the displacement's going to be negative. Equals 0 because VI is 0 times T. Plus 1/2 times negative 1.67 T squared. So 0.5 times negative 1.67 is going to be negative equals negative 0.835 T squared. So these two combine to give us 0.835, and I'm just bringing down the T squared. So now we're going to divide both sides by negative 0.835. That'll go away. T squared is negative 1.4 divided by negative 0.835. That'll be 1.67 is T squared, but we don't want T squared, we want T. So we'll take the square root. It's a good thing that it's a positive number because we can't take the square root of a negative number. So T is going to be 1.29 seconds. I hope that made sense. Rocket-powered sleds used to test human response to acceleration. Rocket-powered sled accelerates to a speed of 444 meters per second in 1.8 seconds. What's the acceleration? How far does it go? So we're looking for D, and we're looking for the A. So that means they give us some other stuff. Rocket-powered sled, I'm assuming it's going to start from 0 meters per second. We're going to end at 444. And the time is 1.8 seconds. That does not sound like a fun ride. Actually, it does sound like a fun ride. Probably pass out, but let's see how we do this. So VI, VF, A, and T, I think VF equals VI plus AT. And we'll figure out D at the end. So we'll figure out the acceleration. So 444 equals 0 plus A, which we don't know, times 1.8. That's going to go away. So 444 divided by 1.8. Divided by 1.8. It's going to be 246.6 meters per second squared. That's going to be your A. That is a very, very, very fast acceleration. So that's cool. Now we can figure out the D. I would say we can do, we can do VF squared equals VI squared plus 2AD. That sounds pretty safe. So VF squared equals VI squared plus 2AD. So 444 squared equals 0 squared plus 2 times 246.6 D. That's going to be really, 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 really fast. So let's see, 444 squared is a really big number, 197,136. 2 times 246.6. That's going to be 493.2 D. So I just combine those. The zero is going to be dropped. So now we can divide both sides by 493. We should get D. 197,136 divided by 493. 399 meters. That is a very, For going that fast, that's a pretty short distance. That was fun. Next, bike accelerates uniformly from rest. So that's my VI is going to be rest to a speed of 7.1 meters per second over a distance of 35.4 meters. Determine the acceleration of the bike. That's easy. I think the best bet, VF squared equals VI squared plus 2AD. So 35.4 squared equals 0 squared plus, just kidding. Just kidding, give me my eraser. VF is not 35.4, it's 7.1 plus 2 times A, which is what we're looking for, times 35.4. So 7.1 squared is 50.41. That's going to equal 0 plus 2 times 35.4. 70.8 times A. That's going to go away. So now we're left with 50.41 equals 70.8 times A. Divide both sides by 70.8. A is going to be 50.41 divided by 70.8. 0.71 meters per second squared. Here's your acceleration. Engineering is designing a runway for an airport. Of the planes which use the airport, the lowest acceleration rate is 3 meters per second squared, and the lowest takeoff speed is 65 meters per second. Assuming these minimum parameters, what's the minimum allowed length of the runway? Okay, so the VI for a plane is going to be 0. The final velocity is going to be 65, and we need to figure out the displacement. Don't care about the time, so it's going to be, again, VF squared. We're using this equation a lot today, huh? Equals VI squared plus 2AD. So 65 squared equals 0 squared plus 2 times 3 times D. So let's play some math. 65 squared equals 4225 equals, that's going to be 0. 2 times 3 is 6. Bring down the D. So we'll divide both sides by 6. That would be 704 meters equals D. So I hope that one made sense. 9, car traveling 22.4 meters per second skids to a stop in 2.5 seconds. Determine the distance. So that's easy. 22.4 is my VI. A stop is my VF. We have a time of 2.55 seconds, and we're looking for the D. Don't care about the acceleration. So, let's see, VI, VF, T, and D. I would say D equals VI, T, but nope, we can't do that one because we don't have time. VF squared equals VI squared plus, nope. Let us, maybe we need to figure out the acceleration. You know what? Actually, all the equations need the, yeah, everything needs the acceleration. So we actually have to figure that out. So I believe the best way to do this is going to be VF equals VI plus AT. So VF is 0, VI is 22.4. A is what we're looking for the moment, times 2.55. So we're going to have to subtract 22.4 from both sides. Get negative 22.4 equals 2.55A. 2.55. It'll give us an A of negative 8.78 meters per second squared. So with that, so now we've got the A of negative 8.78. So now what we can do is we can take that A and go into a different equation. I would say VF squared, because it's easiest, equals VI squared plus 2AD. So VF squared is 0. vi squared is 22.4 squared plus 2 times negative 8.78 times d. So now we can play the game. 22.4 squared is going to be 501. 0 equals 501.76. 2 times 8.78 negative would be negative 17.56 d. So now we're going to subtract from both sides 501 from both sides. 0.76. So negative 501.76 equals negative 17.56 d. Divide both sides by negative 17.56. D will be 501.76 divided by negative 17.56. D is 28.57 meters. So I hope this one was a little tricky. You needed to figure out the acceleration first. Finally, last one. Kangaroo is jumping to a height, or is capable of jumping to a height of 2.62 meters. Determine the takeoff speed. So I think the first thing you have to remember is we're figuring out the initial velocity, but we know how fast the kangaroo is going at the top, and that's 0 meters per second. We know the acceleration is negative 9.8 because once the kangaroo jumps, he's a projectile. And we know the displacement is positive 2.62 meters. So VI, VF, A, and a D, I think the equation to use would be VF squared equals VI squared plus 2AD. So 0 equals VI squared plus 2 times negative 9.8 times 2.62. And this actually gets pretty simple. 0 equals VI squared plus 2 times negative 9.8 times 2.62. That's going to be negative 51.32, but we're going to add 51.32 to both sides. We'll end up with 51.32 equals VI squared, because those will cancel. And we take the square root of 51.32. That will be VI equals plus or minus 7.16. But because the kangaroo is going up, we're not going to take the negative, we're going to take the positive 7.16 meters per second. Which, for what it's worth, that's about as fast as your projectile launchers, your marble launchers were shooting, according to your lab reports. So, see how high your marble can go, that's about how high a kangaroo can go, which is kind of crazy. So 7.16 meters per second is your initial velocity. I hope that helped, and we'll see you in class over the next, we'll see you in class tomorrow.